We are closing out our number play series by looking at cryptarithms, also known as alphametics. In these puzzles, digits from 0 to 9 are hidden behind letters. Two rules govern every problem. Each letter represents one unique digit, and identical letters must represent the same digit throughout the entire equation. Finding these values requires us to isolate specific place values and apply the standard laws of addition and multiplication. By identifying the logical boundaries created by these rules, we can deduce the value of every hidden digit. Look at this addition. T plus T plus T equals UT. In the units column, we see that a single digit added to itself 3 times results in a sum that ends in that same digit. We can test the possibilities. If T is 2, the sum is 6, not a 2-digit number. If T is 3, the sum is 9. If T is 4, the sum is 12. While 12 has 2 digits, the units digit is a 2, not a 4. If we test 5, the sum is 15. This satisfies both conditions. It is a 2-digit number, and the units digit matches our T. This tells us T is 5 and U is 1. By focusing on the constraints of a single column, you can eliminate most incorrect options without having to guess. This next equation, K2 plus K2 equals HMM, introduces multiple unknown variables across 3 different columns. We begin with the column where we have the most information, the units. Since 2 plus 2 is 4, we know that M must be 4. Because the sum ends in MM, the tens digit must also be 4. Take a moment to look at the tens column. What single digit, when doubled, results in a number ending in 4? 7 plus 7 is 14. This gives us the 4 we need for the tens place and carries a 1 over to the hundreds place. This reveals that K is 7 and H is 1. Even with multiple variables, the problem resolves systematically when you work through the place values from right to left. These logical rules also apply to word problems. Imagine a light bulb that is currently on. If the switch is toggled 77 times, we can determine its final state. 1 toggle is off, 2 is on, 3 is off, and 4 is on. The pattern shows that an even number of toggles returns the bulb to on, while an odd number leaves it off. 77 is an odd number, so the bulb will be off. We can use a similar approach to see if 50 loose Encyclopedia sheets could have a page number sum of 6,000. On any single sheet, the front page is an odd number, and the back is the following even number. Adding an odd and an even number always results in an odd sum for that sheet. Because we have 50 sheets, an even quantity, we are adding 50 odd numbers together. This will always result in an even total, which makes a sum of 6,000 mathematically possible. Parity rules allow us to verify the possibility of a scenario without performing the full arithmetic for every individual piece. Here is your final problem. UT plus TA equals TAT. For your starting point, look at the hundreds place in the sum. When adding 2 2-digit numbers, what is the only digit that can appear in that hundreds column? Apply the column deduction steps to find the values for U, T, and A, and share your results in the comments. As you solve it, keep these principles in mind. Each letter is a unique digit. Start your analysis with the units column, and use parity rules to narrow your options. Using these logical constraints allows you to navigate complex numerical puzzles with precision. Thank you for finishing Chapter 6 with us. We will see you in Chapter 7.